Welcome to the last part of number systems, part 2, where we continue with approximations and scientific notation. In this last part, we're going to take a look at two concepts. The first is rounding off, the other one is errors in measurements. Given a measured value, which has been rounded to a certain number of decimal places, there is always a minimum value and a maximum value of that number. So let's say we have this number 2.345. So there is a number, there are different numbers which this 2.345 can be, but we can't tell if it has already been rounded off. Okay, so the possible values of 2.345 might include 2.3454. So if you look here, 2.3454, if we round off to 3 decimal places, then this 4 is less than 5, so we're not going to get anything. We'll just discard it, mean that this 2.3454 will just be 2.345. Then it can also be this number 2.3453. When we try to round off 5, we look at 3 is less than 5, so we can't get anything from it. So this can also be this. It can also be this. It can also be this. It can also be this. So all these numbers, there is a chance that they are the ones which have been rounded off to these. Okay, now if you pay attention here, if we say, if you look at the pattern, I was reducing from 4 3 2 1 0, like 0 1 2 3 4. So what about if we put 5 here? If we put 5 here, 5 is greater than 5, so when we round it off, it will become 6. So 2.345 cannot be represented by 2.3455, because when you put 5, this becomes 6 and this will be 2.346. So the maximum number we can go, the maximum number possible is 2.3454. What about the minimum number? So is it possible to know the minimum number, the minimum value that this can represent? So the minimum value also, let's try to go down. We see how the lowest number we can get. So after 0, what we can do is we can try to put 4 here, like this. You can see this to be like 50, so it becomes 49. So it will be 49 here. So if it's 49, if we round off 9, then this will become, if we round off 4, we get 9. 9 is greater than 5, so we'll put 1 here, and it will be 2.345, which is this 2.34. Which is this 2.345. So with that being said, we can also go down to 8, it will be the same, to 7, it will be the same, to 6, it will be the same, to 5, it will be the same. But if we go below 5, like 4, it won't, because if we have 4 here, then rounding 4 to rounding this 4, if we have 4 here, if we look at this 4, it's less than 5, so it's a 0. We can't get a 1 from it, so this will be 2.344 instead of being 2.345, which we are looking for here. Therefore the lowest number is this one, 2.3445. so this is how to determine the minimum and maximum value, but this is cumbersome. Is there a better way, one that doesn't involve this analysis? So I did this so that you have an insight into what the minimum and maximum value mean of a rounded off number. So to get the maximum value of this, what you do is you just turn all these numbers into zeros till the last number. So all these numbers, you turn them into zeros. So 0.000. Then when you turn them into zeros, you add 4. Okay, so what you do is you get this number, you do it plus this number. This number is the one that you get from here when you turn everything into 0. So the 2 has been turned into 0, the 3 has been turned into 0, the 4 has been turned into 0, the 5 has been turned into 0. Then at the end, you add 4. So this number that you get, you add it to the original number, 2.345 plus 0.0004. What you're going to get is the maximum value. The minimum value, you do the same, but instead of 4, you add 5 here, and you do minus instead of plus. Okay, so let's try to get the maximum value and the minimum value. So maximum value 2.345 plus 0.0004. Okay, So if these had 10 numbers, then we could have 10 zeros and 4 at the end, which means the 11th digit is going to be 4. So we're going to add these two. So when we add here, remember how to add decimal points. You align the points like this. They should be in the same line, in the straight line like this. Then if you look here, 4 has no its corresponding number, so there's nothing here mean that it's a 0. If you want, you can put a 0, but if you want, you can just know that there's a 0. So 0 plus 4 is going to give you 4, 5 plus 0 is 5, 4 plus 0 is 4, 3 plus 0 is 3, 2 plus 0 is 2. So that's your maximum value. For the minimum value, we do the same but minus, and of course instead of 4 we add 5. So this number, we're going to do this. So note that the original number was 2.345, but here I added the 0 so that it corresponds to this. When you are dealing with minus, it's very important to put a 0, otherwise you can do it even without a 0, just like we did here, but there's no harm in just putting a 0 here. So when we want to subtract 0 minus 5, of course it can't, so I have to get 1 from here. So this will be 4, 1 will be here, and it will be 10 minus 5. I won't teach you how to do my subtraction. This is so basic. If you're not sure, of course, we can discuss. You can let me know. So 2.3450 minus 0.0005, it will give you 2.3445. So this is your minimum value. We go to errors in measurements. So when you're measuring, there are two numbers that you need to be aware of. There's always a true value of something and a measured value. You can measure your height to be 5 meters, but maybe your true height can be 4.9 meters. Because when we're measuring, we make some approximations, we approximate. So there's always a difference between the true value and the measured value, depending on the accuracy of the instrument you're using for measurement. So the absolute value, sorry, let me say that again. So the differences are what are called errors. Okay, so there's the first one is called the absolute error. So the absolute error in a measurement is the positive, the word absolute means positive, is the positive difference between true value and measured value. So if you subtract true value and measured value, what you're going to get is the absolute error. But the answer should always be positive. If it is negative, you will forget about the negative. So absolute error is always given by this straight line. Then you write true value minus measured value, then you put another straight line. The straight line means that you're going to get the positive number from this. For example, if you put true value and measured value, get -2, then the final answer is going to be 2. You discard the negative. The second type of error is called relative error, which is just the ratio of the absolute error to the true value. So once you find the absolute error, you can divide it by the true value. What you're going to get is the relative error. So relative error is absolute error divided by true value. The last one is percentage error, which is the expressing of relative error as a percentage. So percentage error is just you get your relative error multiplied by 100%. So percentage error is relative error times 100%. Let's take a look at example. So when it comes to this kind of errors, there are two types of questions. The first ones are these where they give you the measured value and the true value. So given the height of the building is 10 centimeters and the measured height is 10.7 centimeters, calculate first absolute error, second relative error, third percentage error. They have given us the true value and the value that was measured. So to find the absolute error, we just subtract. First, let's write the data. True value is 10 and measured value is 10.7. So absolute error is just true value minus measured value. 10 minus 10.7, which is going to give you negative 0.7. But we get the positive. So this is what this guys mean. So we forget about the negative. Then we have 0.7. So this is the absolute error. Then when it comes to the relative error, we just divide the absolute error by the true value. So the absolute error is 0.7 divided by the true value, which is 10. So it will give you 0.07. Then the percentage error, we just multiply the relative error by 100%. So 0.07 times 100%, it will give you 7%. Then example 2 has to do with a value that has been rounded off. So in this case, let's say the question is, given the height of a building is 10 centimeters and the measured height is 10.7 meters. Sorry, this is the repetition of that question. Let me just discard it. So let's say you have this number 5.28653. Okay, so when you want to find out to know the relative error of this one, there's this pattern that you should follow. So the relative error is based on the smallest measurement possible. So when this was recorded, what is the smallest measurement possible? So the way, if you want, you can think of it as the smallest measurement possible. The fact that they were able to record this this number, it means the smallest measurement possible will be determined by the number here, okay, which is supposed to be here. That might be hard to just wrap your head around it. The other way to think of it is the relative error of such a number is simple as this. So let's say the number is 5.28653. If it is rounded off to 4 decimal places like this, because rounding off 3 will give us 5. So the relative error is just everything here should be zeros, then at the end you put 5. So it's going to be 0.00005. 0.00005. This is the relative error. Okay, so that's how to go about it. Let's say we have this, and the same number has been rounded off to 3 decimal places. So 3 decimal places, we're talking about rounding off this 5, then this becomes 7. So again, all these will be turned into 0, then at the end we'll put 5. So it will be 0.0005 like this. This is the relative error. If the question, if it has been rounded off to 2 decimal places like this, all these 2 zeros at the end we put 5, just like this. If it is 5.3 to 1 decimal place, all these zeros at the end we put 5, just like this. So this is how to get the relative error when a figure has been rounded off. Let's take a look at an example. Given the height of the building was measured to be 10.7 centimeters to 1 decimal place, calculate the relative error and the percentage error. So the solution is, so it's 10.7 to 1 decimal place, and you know what I'm talking about, turning the numbers into zeros at the end, putting 5. That's the relative error. So the relative error is just 0.05. So here it's 0, here it's 0, here it's 0, here we put 5. You might ask, why is that we don't have 0.05? Because 0.05 is the same as 0.05. Writing 2 zeros in front of a point is not the standard way of writing numbers. 2 zeros means nothing. It's better to write 1 0. Then the percentage error, of course, is just multiplying the relative error by 100%. So this will be 5%. So this marks the end of this topic. Hope you have enjoyed how simple it is. Otherwise, happy solving.